Hey, this is Kirk from the DynamoDB team, and today we are talking about change data capture for DynamoDB. Change data capture for Amazon DynamoDB, or as some people call it CDC, replicates all item-level modifications to a data stream for you. It's an optional feature, so you will have to enable it in order to use it. CDC for DynamoDB comes in two flavors, DynamoDB Streams and Kinesis Data Streams for DynamoDB. Each flavor has their pros and cons you need to be aware of, and we will get into the specifics of that in this video. Let's first talk about what change data capture is used for. The first one is database triggers. Now, unlike a traditional relational database management system, DynamoDB does not keep triggers with the database itself. The reason for this is beyond the scope of the video, but the functionality of triggers is definitely still there in DynamoDB. It involves the use of DynamoDB Streams and AWS Lambda. You enable Streams, then enable Lambda to listen to that stream. Pro tip, check out event filters with Lambda. When enabled, they filter through a stream in real time looking for specific data or events you tell it to, and only invoke a Lambda function when the filter is satisfied. Since the filtering logic is not in the Lambda function itself, doing this can save you a lot of coding and money. The next use case is complex aggregations. There are times where you want to be able to do complex rollup aggregations on data, and they are faster, cheaper, and scale better to do outside of DynamoDB. For example, say you need to increment a value for a user when they add a new document to an app. I could have a Lambda watching for objects of that type in a DynamoDB stream and then increment a value in the database for that user when that happens. These kind of aggregations scale exceptionally well as compared to doing more complex aggregations like you were used to doing in other databases. Another example is streaming your data to other AWS services to do more things. For example, you use DynamoDB for high-speed, low-latency data access, but there are times when you need other specific functionality using that same data. Maybe you're interested in using SageMaker to do some machine learning on that same data. You can stream the data with Kinesis Data Streams for DynamoDB to services like Amazon Simple Storage Service, OpenSearch Service, Redshift, and others to do different things with data that you already have. One additional note here is that both flavors of CDC offer encryption at rest. Let's jump into the first flavor of CDC for DynamoDB, DynamoDB Streams. DynamoDB Streams captures a time-ordered sequence of item-level modifications to a table and stores this information in a log for up to 24 hours. Your application can, in near real time, access the stream and view the items as they appeared before and after they were modified. Whenever an application creates, updates, or deletes items in the table, DynamoDB writes to the stream what is called a stream record. A stream record contains information about a modification to a single item in a table. DynamoDB Streams helps ensure that each stream record appears exactly once in the stream and that the stream record appears in the same sequence as the actual modification to that item. My favorite feature is when doing database triggers and using AWS Lambda on the DynamoDB stream, reads are always free. Combine that with Lambda's event filtering so you only invoke functions in those specific circumstances, and you can get a lot of serious functionality for very little money. For any other reads of DynamoDB streams, the first 2.5 million reads every month are free. For more specifics on the cost component of change data capture, please be sure to check the link in the description to the video for the documentation. Now let's talk about some of the specifics of Kinesis Data Streams for DynamoDB. With KDS for DynamoDB, it allows you to replicate data directly from DynamoDB into Kinesis Data Firehose. This matters because you can direct Kinesis Data Firehose at other services for near real-time data streaming. The most common is pushing data to Amazon S3 for use with Athena and machine learning products such as SageMaker. A few things to note about KDS. First off, data changes are inserted into Kinesis data stream records asynchronously and might appear in a different sequence than the item changes occurred in DynamoDB. In addition, it is possible for the same item notifications to appear more than once in a stream. If you need to identify the actual order that the item modifications occurred, check the approximate creation date time attribute of the stream record. For more specifics on this, check out the change data capture for DynamoDB documentation linked in the description. Quick tip for you. When you create a Kinesis data stream, it's a good idea to create the stream in on-demand sharding mode, not provision mode. And then once you run it for a while and get some performance metrics and know how many stream shards you'll need, Then perhaps look to switching to provision mode to save money. And now it is time to do a quick demo to show you exactly how to turn on Change Data Capture for DynamoDB. I'm on the Export and Streams tab of my table. I'm going to click Enable. I already have an existing stream here, so I'm going to select that one, but you could create one new here if you wanted to. Going to click Enable Stream, and now it is enabling. I'm then going to enable DynamoDB Streams. In this case, I'm going to turn on new and old image, so all item changes are in the stream, but for which option is best for your workload, please check the documentation. I click Enable Stream, and it is now enabled as well. That's how easy it is. In summary, Change Data Capture for DynamoDB comes in two options: DynamoDB Streams and Kinesis Data Streams for DynamoDB. Use Change Data Capture for DynamoDB for things like database triggers with AWS Lambda and integrating your existing data with other AWS and third-party services. Thanks, to be on the lookout for more core concept videos here and on our Twitter handle @DynamoDB.